Hi, my name's Kate Selway. I'm going to be talking to you about the AuScope supported GRIT project, that's Geophysical Research Infrastructure for Antarctica. I'm from UniSA and I'm giving this talk also on behalf of Anya Redding and Matt King, who are at UTAS. Over here. So I'm going to start by talking about the rationale for this project and for this funding. And there's really that really, as we all know, there's an urgent need to understand and predict Antarctic ice loss. It's really one of the most pressing challenges of our time. What I'm showing here is ice loss estimates from GRACE gravity satellite data over Antarctica. What you can see from this is that the majority of the current ice loss is in West Antarctica. And there's, as there should be, there's a lot of research going on to monitor and understand that ice loss. But East Antarctica, really everything over this entire side of Antarctica, is currently contributing less ice loss, but it has the potential, because there's so much ice in East Antarctica, it has the potential to contribute to a lot of sea level rise. So it's really, really vital that we are closely monitoring the behaviour of the ice in East Antarctica and also understanding the controls on its stability so that we're able to make accurate predictions of future sea level rise. For us in Australia, we make territorial claims over a lot of East Antarctica, and we also have all of our Antarctic bases are in East Antarctica. So we have, you could consider it a responsibility and certainly an opportunity to really be leading this, this challenge of understanding ice stability in East Antarctica. And to do that, we need geophysical instruments to be able to measure what's going on. I'm going to talk about two different reasons that we need that geophysical instrumentation. And the first is because when we have deglaciation and the loss of an ice sheet like we're seeing currently in Antarctica, the solid Earth responds to that deglaciation in a process called glacial isostatic adjustment, or GIA. So when we have satellite data like the gravity GRACE data that we saw the result of in the previous slide, those satellite data measure the ice mass loss, but they also measure the solid Earth response to that ice sheet ice mass loss. And we need to be able to understand exactly how much ice we're losing. We need to be able to take out that solid Earth component. And we need geophysics to do this. We need geophysical data to measure that Earth uplift as the Earth rebounds in response to that ice mass loss, and also to measure mantle viscosity. So to measure the Earth rebound, we do that with GPS or GNSS, Global Navigation Satellite System stations. And this is really Matt King's expertise. So these are stations that are deployed on outcropping rock within Antarctica, and they measure the solid Earth uplift as the Earth rebounds as the ice is lost. So on the right, you can see a map of the current GNSS stations around Antarctica. And you can see that there's really not many of those observations within East Antarctica. So we need more of these observations. And on the left is how important those observations are in calculating then that Earth uplift and the response to that ice loss. So having more of these GNSS stations is going to be really important to understand how the Earth is behaving in Antarctica. But even with those observations, then what they can measure is an immediate elastic response to the ice loss. But there's also a very long-term viscous response to the ice loss. So because the mantle is viscous, it's going to respond really slowly to stress changes. So the mantle in Antarctica currently is still responding to mass changes that occurred thousands of years ago. And to be able to constrain this properly, we need to be able to use geophysics to constrain what the mantle viscosity is. And mantle viscosity can be best constrained with a combination of seismic and MT data. So on the right is a map of sort of the current state of play of seismic stations that are available for this analysis within Antarctica. And again, you can see there's not very many of them within this really vast area of East Antarctica. And then in the middle, the seismic models that come from those seismic stations that are then often used to kind of directly infer mantle viscosity just from that seismic data. But there are a few assumptions that need to be made if we're just going to use the seismic data. If we also have MT data, we can make much, much more accurate constraints of mantle viscosity. But on the right is the location of the current MT measurements. Some of them are small surveys, some of them just individual sites within Antarctica, obviously even less than the seismic constraints. So we really need more of these observations if we're going to be able to constrain mantle viscosity within Antarctica and then feed that in to make better estimates of how quickly the ice is currently being lost within Antarctica. So that's what we need the geophysics for, to understand that kind of broad scale ice mass loss. But another thing that geophysics can be really useful for is understanding the controls on the ice sheet stability. And basal melting of the ice sheet is one of those really important controls. Essentially, if the base of the ice sheet or the base of a glacier is melting, that provides a lubricating layer that allows that the glacier or the ice to flow much more quickly, and can mean that the ice sheet can collapse much more quickly than if there is no basal melt. This is just an example from Greenland, where surface melt lakes are draining to the base of the ice sheet and then allowing that ice to flow much more quickly. So with MT data, again, we can measure that basal melt even beneath quite thick ice, and seismic instruments can measure ice quakes from that ice motion. So AuScope support for this GRIT project is currently to fund the purchase of some specialised Antarctic MT instruments. And so this is still in the process of purchasing and building up these instruments, but the goal of these instruments is that they will eventually be based in Antarctica, so they'll be there ready for use by people. They'll be field ready. There are obviously instruments for Antarctica need to be tough and need to be able to deal with the cold, but there are also other specifics that we need for the electrodes for Antarctic conditions that are different from more temperate conditions. So they'll be field ready for Antarctic conditions, and also designed to be easily deployable, including by non-specialists. So then the hope is that if you have somebody going out to a place and doing some other kind of scientific work, that maybe they could take one of these instruments along with them and do a deployment without needing sort of an entire MT project to be funded down there to build up our coverage of this data across Antarctica. So that's the AuScope support for the MT instruments, and that's combined with existing ARC and AuScope support for GPS instruments for East Antarctica, and also additional seismic instruments. Is just an example in the middle of a seismic deployment within Antarctica. So together with all of this support, we're really, as Australia, building up an enhanced geophysical instrument pool to, as I say, be able to really characterise what's going on in East Antarctica and improve those models of ice sheet stability and of future sea level rise. And so this AuScope support is contributing to a number of projects, and really importantly to ACES, the Australian Centre for Excellence in Antarctic Science, which is being led by Matt King, and Anya and I are CIs on that project. And there's a big field campaign planned for the Denman Glacier region as part of that. And as you can see, that's circled in the green on the right. And that's one of these regions where we currently have a reasonable amount of ice mass loss within East Antarctica, and one of these regions where we really need to be able to monitor what's going on and understand these controls on the ice behaviour so that we can make, as I say, accurate predictions of how that ice is going to behave and what sea level rise is likely to be. So thank you. We're really delighted and grateful for the AuScope support for this work. So thank you all.